Good evening. Well, that was pleasant and unexpected. My name is Stephen Offelt, and on behalf of the McDevitt Center for Creativity and Innovation, it's my pleasure to welcome you and to thank you for coming out in this January weather here in mid-March to listen to Dr. Russell, who will be giving the 5th lecture in our ongoing series of talks devoted to the subject of science and religion in modern America. In just a moment, I'll introduce the McDevitt Chair of Religious Philosophy, Father George Coyne, who's taking a break from his busy television schedule to be with us this evening, who will introduce our speaker. But I want to, first of all, invite you to the 6th lecture and final lecture this year in our series, which will be on April 25th, when Nancy Murphy from the Fuller Theological Seminary in Pasadena, California, will be here delivering a talk entitled Emergence, Systems, Organisms, Persons, related to the matter we were discussing over dinner, I think. So I'd like to invite you to that lecture, April 25th. I'd also like to let you know that all of the previous lectures in our series can be viewed online by going to www.lemoyne.edu McDevitt Center. The talks are available through the McDevitt Center archive. They're also available on YouTube. And these other sources of information, these are ways that we invite you to follow what the McDevitt Center is doing, both further information about our Science and Religion initiative, but also other initiatives that we're doing. Our blog will provide you with all kinds of really terrific information about our speakers, other talks they've given, links to information about them, books, and so on. So I invite you to check us out through those media. And now I'm happy to yield the floor to my friend and colleague, Father George Coyne.
Good evening to you all. I know why you're here. It's nice and warm inside here, right? No, seriously, I love doing introductions, actually, but it's always difficult to do an introduction to a very close friend and remain a friend at the end of the introduction. But I'm going to try to do that. Robert John Russell, as an undergraduate, he triple majored in physics, religion, and music at Stanford University. My suggestion is that as a young man, he either didn't know what he wanted to do, or that he really wanted to do a whole lot. And I think you will find out that the answer is he really wanted to do a whole lot. He holds a Ph.D. in experimental physics from the University of California, Santa Cruz, a Master of Divinity and Master of Arts in Theology and Science from the Pacific School of Religion. He's the founding director of the Center for Theology and the Natural Sciences at the Graduate Theological Union in Berkeley, California. He's an ordained minister in the United Church of Christ. What I am proud of, if I may be permitted, and I have to be permitted since I'm here and you're there, I'm most proud personally that Bob became the principal architect of a series of conferences inspired by Pope John Paul II and jointly carried out by the Vatican Observatory and the center in Berkeley that I've just mentioned, which was founded by Bob. The theme of those conferences was the study of scientific perspectives on divine action. Very simply asked, might science help us to understand how God acts in the universe? You can imagine, therefore, that we are in for quite a treat tonight as I invite Dr. Russell to speak on cosmology and creation. Bob, it's yours.
Thank you, George. That was a beautiful and kind introduction, and we are more than friends. In fact, I want you to know that we all dedicated the last volume in the series to George and embarrassed him by reading the dedication when he was a fellow at the Center for Theology and Science. So it's been a privilege to know George, work with him. Thank you to the McDevitt Foundation Center for inviting me here tonight, for the gracious opportunity to talk with you about cosmology and theology. And in fact, I want to propose an interaction model in which theology, philosophy, and science interact mutually and creatively. So the real title here, as you can see when we switch over, is going to be Scientific Cosmology, Philosophy, and Creation Theology. Are we on? Great. Thank you very much. Good staff. So, creative mutual interactions. I want to suggest that there are three ways in which science, philosophy, and theology can interact, and we'll be looking at these throughout the talk, and oftentimes you'll see even more than one at work. So one is so-called context of discovery. This is where theories are constructed in science, and here philosophy and theology play a role, a constructive role in the theories that are formed in science, even though as scientists, George and I wouldn't typically talk about this, but in fact it's an important role, and I'm going to point that out tonight. There's also a context in which scientific theories are tested or justified against evidence. And here, philosophy and even theology can play a role in which theory you choose to work on and how you choose to weigh the evidence in favor of it. So again, a second way in which philosophy and theology are in conversation, in interaction with science. The third is the normal way we think about, you take a given scientific theory, Big Bang or quantum mechanics or neurosciences, and you interpret them theologically and philosophically. That's called the context of interpretation. And tonight we'll see each of these different ways of relating present in the actual history of contemporary cosmology. So first, a background to modern science and the historical role of philosophy and theology in the rise of modern science in the West. So modern science arose through the confluence of two major streams in Western intellectual history. On the one hand, you have the Greek logos philosophy, going back to the pre-Socratics and stretching throughout Plato, of course, and Aristotle, and the Stoics. And this is the assumption that the universe is rational. The universe is, in fact, structured by the logos, the rationality of nature. That tradition was taken over by early Christian apologists, and we understood the logos from Greek philosophy to be the logos of the Word of God in John. So this formed a nice connection between secular or pagan Greek philosophy and Christian theology as Christian theology advanced post-Constantine into the West. Second is the biblical tradition of creation ex nihilo, which both Jews and Christians share. And this is the notion that the universe is created out of nothing. That is, it simply is a creation of God. Think of the Genesis 1 account in which God creates by God's Word. Nice connection again to Logos. So God doesn't create out of something primordial. God creates ad omniscia. And because of that, because God creates the universe as a free creation, the universe needn't be, and it needn't be the way it is. You can't deduce what the universe is like from logic. You can't use Greek syllogisms to move from first principles to the way the universe is. You can't deduce that the universe is four-dimensional. You have to go and see. Oh, to use a philosophical term, the universe is contingent. It needn't be, and it needn't be the way it is. So the only way you can have true knowledge is to do experiments, right? To go and see what's actually there. So the basis of experimental science is that the universe is rational, so it's intelligible. It wouldn't be intelligible if it weren't rational. And it's intelligible implies you can represent it by, for example, mathematics, the laws of nature. So when you and I write down an equation like Newton's law of gravity, we're presupposing that you could do that and that it would work. It could be the wrong law, but it in principle could be right. It could apply to the universe because the universe is a free creation of God. You only know it through experiment, and because it's rational. So again, contingency means if it need not exist, then genuine knowledge of the universe can only be obtained through experiment. That is, experimentation is required to know about the universe. Now, we assume this in doing modern science. What I'm suggesting is that the way we do modern science, whether or not you're a Christian or a Jew, if you're an atheist or a Buddhist or an agnostic, if you're doing modern science, you are in essence presupposing a sort of biblical Greek view of nature. So in the practice of science, you already assume that the universe is intelligible and contingent. That is, experimental methods count. And that's an amazingly powerful argument for the in-depth interaction between philosophy, theology, and science. Even if scientists in practice don't know they're doing that, that's what's being presupposed. Thus, the scientific method is based on this philosophical and theological foundation. We call it, technically, methodological naturalism. That is, scientific theories presuppose a method in which you explain effects as due to natural causes. Right? So why is my laptop here? I put it here. Right? There's no divine mystery to that. Now, Christians will then interpret that whole scientific picture as pointing to a divine causality. But the explicit acts of nature, the explicit effects, like your being here tonight, is due to natural causes. You chose to come, and you walked into the door. So methodological naturalism is an explanation of nature through natural causes. It doesn't say there are non-natural causes. And most Christians believe there are divine causes at work in nature, but there are certainly natural causes. And therefore, it's quite fair to say that scientific theories should not invoke God. When a scientist says, don't put God into my equations, they're right. Right? When they argue against intelligent design, you shouldn't invoke an intelligent actor in the biological and physical process of nature. They're right. Because they're following the theological understanding of nature which led to science. So it's also crucial at this point to point out to, especially to my Christian colleagues who are conservatives, that because methodological naturalism doesn't evoke God as part of the explanation of the processes of nature, doesn't mean God doesn't exist. That is, methodological naturalism does not prove metaphysical naturalism, that all there is nature. Science is incapable of proving whether God exists. What I'm suggesting is science is based on the assumption that God is the creator of the universe. So it's an interesting relation between God and the universe. Okay. So methodological naturalism assumes we can explain states of the universe through natural causes, but does not argue that God doesn't exist. Now, another rise of modern science was the collapse of Aristotle's mode of explanation. Aristotle gave the West a mode of explanation of four causes: formal, material, efficient, and final cause. This worked great for millennia. And of course, St. Thomas adopts this method of causality in his massive works on theology. And today, if you speak to a neo-Thomist, and if you're here, you're speaking to neo-Thomists, you'll hear talk about not just efficient cause, like gravity, but you'll hear talk about material, formal, and final cause. Now that's very important in a neo-Thomistic framework, but it's also a matter of fact that scientists tend not to use all four causes. They tend to talk about efficient cause. Now they'll talk about material and final cause perhaps in terms of some sort of inherent purposes, but basically the causal structure of Aristotle has been reduced to efficient causes. And when George explains to me about the formation of the solar system, he'll talk about the history of planetary formation, the way in which the meteorite, the asteroid belt formed because of Jupiter's influence. Those are explanations by efficient cause. So it's another sort of philosophical move. What I want to suggest here is that we didn't lose the role of philosophy when we reduced the mode of explanation from Aristotle's 4 causes to modern science's 1 cause, efficient cause. It's a philosophical move. It's not a move away from philosophy. It's a move between different kinds of philosophies. Right? Oftentimes scientists will say, well, we don't use philosophy in science. Well, of course you do. You just use a different form of philosophy than pre-Copernicus used. Let's look at a specific set of theories that take us directly to modern cosmology, which we're going to talk about tonight. So first is the classical principle of relativity. This is Newton's principle. It's a profound break with Aristotle, right? Because for Aristotle, things like rocks and fire sought their natural places. Rocks seek the earth, fire seeks the heavens. For Newton, based on Copernicus and Galileo and then Tycho Brahe and others, absolute motion and rest are meaningless concepts. There is no such thing as absolute motion or absolute rest. All there really is relative motion. All motion is relative. And you think about this in terms of, say, tossing a football while you're on a boat. Right? You're on a ship and you're crossing the ocean, and you toss a ball back and forth. Now, from your point of view, if you don't see the ocean, you don't see your motion, you can't tell that you're moving. You toss the ball. It works the same as if you're doing it here. There's no difference between me tossing George a ball here or me and George being on a bus tossing a ball back and forth. There's no absolute difference. It's simply relative motion. Now that gets embodied in Newton's laws, so I wrote down F equals ma just to put the equations down. But it's important to recognize that while we learn as physicists how to solve those equations for various kinds of forces like gravity or statics or other kinds of problems, the laws themselves reflect this underlying philosophical notion that there's only one relevant cause, efficient cause like gravity, and there's only one basic kind of motion, that's relative motion. Newton also produced a classical theory of gravity. This embodies that same principle, that all bodies accelerate at the same rate. You can't tell from falling bodies which ones are really falling. If you ever read the wonderful book by Galileo, the one that got him in trouble, Dialogue on Two World Systems, he goes into extensive discussion with the Aristotelians about whether or not you could tell whether the Earth was moving. And it turns out that you really can't. So he drops his ball from the Leaning Tower of Pisa, and it falls straight down. It doesn't fall to the left. Well, why not? Because his argument said, in fact, it really can't. Because the Tower of Pisa is moving with the ball. They're moving in relation to each other. And so, in fact, the ball is moving in a curve if you were somehow off the Earth and looking at it. But on the Earth, it's moving straight down. Motion is relative. He combines his classical mechanics and classical gravity to produce Newtonian cosmology. In Newton's cosmology, the universe is infinite in space, but is static and eternal. For Aristotle, the universe is finite in size, but eternal. For Newton, the universe is infinite in size, but eternal. Now, those were really philosophical arguments he put into his equations in order to solve them for the distribution of mass and energy in the universe. So even Newton's model of the universe is a model which makes certain philosophical assumptions about the universe and then gives you an actual picture of the universe as infinite in size and space. Interestingly, we can talk about this in the Q&A, God plays an important role for Newton that we should note. It's God's sensing of the universe through absolute space and time, which gives the universe its actual physical states. So God is very much an actor in Newton's universe, but an actor that's so uniform in action that there's no difference in action, therefore no detectable action. It isn't as if God acts more here than there. But in, again, the details we can come on in conversation, God makes it possible that the universe has actual states, like we're actually here. Okay, so it's a very interesting relation about the divine action George mentioned, that God's action gives the universe its states, but not in a way in which you could test to see if God's actually acting, because it's uniform action. Let me just point out, and this is moving to the third kind of interaction, where you're looking at a given science and its interpretation or the reaction to it in culture, in religion and philosophy. Newton's science, Newtonian physics, led to what's oftentimes called the mechanistic worldview. This is a worldview in which all you have is matter in motion. There's no sense of the person as a self, or if you will, a soul. The universe is a sort of a huge container, and all you have is particles. The reaction to Newton's worldview was really what we call deism, the notion that God may have been required to create the universe, but God doesn't act within it. God makes no differences to the universe. It's a very mechanistic, mechanical view of nature. In many ways, this leads to a kind of reductionism, that everything about human life can be reduced to our material components. And all our experience that has to do with feelings or values or motivations, joy or sadness, are very ephemeral, very pseudo-phenomenal. We experience them, but they aren't real about the world. There's a great quote from E.A. Burt: "Man became a puny, irrelevant spectator of a hard, cold, colorless, silent, and dead world." So here is an interpretation of science, but the science it's interpreting already has these philosophical views built into it. We've already excluded purpose, right, or final cause as a mode of explanation. So maybe it's not surprising to find us being treated with our purposes as irrelevant, because after all, science sees no purpose in nature. You can see how the role of philosophy in the formation of science, then the role of philosophy in the interpretation of science sort of go together in almost a vicious circle. 19th and 20th century reactions. Religion is reduced to purely to the realm of morality and personal piety. So God is limited to the subjective sphere of human existence. For us Protestants, a good example would be Protestant existentialism or liberalism. The notion of religion is really a moral code, a way you form society, or personal piety, and not about the grand purpose of nature, God's action in the world, God's future for the world's transformation and resurrection, new being. Or atheism. One of our close colleagues, Michael Buckley, has written profoundly on the way in which the philosophical shifts that led to modern science and to mechanism laid the groundwork for the rise of modern atheism as a phenomena. We've had atheists in history, in Western history. In a certain sense, Socrates was an atheist because he rejected the Homeric gods. And he was executed for his atheism because he didn't agree with the state religion. But we never had a phenomenon like atheism before. It was really the rise of the Enlightenment, the political revolutions for independence in France and England, and the role of Enlightenment science, that is, this mechanistic view of the world, which legitimated atheism. So when you hear Richard Dawkins saying, biology gives me the permission, in fact, supports me in my atheism, well, he's probably right in some ways, but it's not the first to say it. It goes back 2 centuries. Right? So ask yourself the question, why is there a phenomenon of atheism in our time? And one part of that picture is the rise of science, which is neutral to theology, but then its rapid interpretation as mechanistic. It's a philosophical interpretation, and its rapid theological interpretation, which is atheism. So atheism is an overlay on mechanism, which is an overlay on Newtonian science. Okay? It shows how complicated that mode of hermeneutics, of interpretation, is, the path is from science through philosophy to a theology of atheism. So God is dead, Nietzsche, Feuerbach, Freud, Marx, Bertrand Russell, not the same, no family resemblance, Jacques Monod, Richard Dawkins, and Stephen Weinberg. The rise of what we call militant atheists in the last 2 decades is sort of surprising because their arguments are sort of baby arguments compared to these monolithic arguments for atheism. I mean, these arguments are profound. All I'm pointing out is that there is a certain role in science. It's the role of being co-opted philosophically by a mechanistic view of the world. And then that's being co-opted or used to form an atheistic view. Right? So to attack science as atheistic as conservative fundamentalist Protestants do is to tragically missed the mark and attacked the victim instead of attacking the victimizer. It isn't science which is atheistic, but it's been co-opted by atheism. So the attack of us, for us Christians to challenge that, we need to challenge the atheist who claims science leads to atheism. But I can understand how they make that move, because once you have a mechanistic view of the world, that you and I are just matter in motion, and there's something of dignity about you or me, or our feelings aren't really grounded in reality. Once you've gotten that far distance from the universe, it's not surprising that the most compatible view theologically is, well, there's no God. It's make it of yourself. Jacques Monod, the old covenants and runes, and we've come to realize we're alone in the universe. That's Jacques Monod. Okay. Special relativity. We have 2 more slides to go, and we're onto cosmology. In Einstein's special relativity, notice the word relativity. He's picking up on Newton's principle of relativity. What Einstein does here in constructing one of the 2 pillars of modern science, right? Relativity and quantum mechanics are the bastions of modern physics, 20th century physics. It's called relativity because Einstein is saying, I'm going to construct my theory based on the principle of relativity, which comes from Newton. Now I'm going to call it special relativity because I'm going to apply it to a special case, and that is electromagnetism. There's a great story behind all that, which I'll be happy to talk about. But what I want you to take away from this is that what we think of as E equals mc squared and all the weird paradoxes of space and time in the block universe, all the stuff we associate with relativity, are all fallouts. They all come out of, they fall from the equations Einstein constructed, which he did to adopt Newton's principle of relativity to the phenomena of E and M, electricity and magnetism. So you've got the principle of relativity in classical mechanics extended to electromagnetism, and then because of doing that, you get space-time diagrams, you get the equivalence of mass and energy, explanation of why the sun is 5 billion years old, explanation of what becomes nuclear power, and so on. Okay? And his given reason for constructing special relativity the way he does, the actual equations that George and I mastered when we were kids, right? The actual equations he gets are because they're the simplest form in mathematics to represent the principle of relativity applied to E and M. The equations he writes down are the simplest equations to capture the principle of relativity when applied to electromagnetic phenomena. You could do it in a more complicated way, but the simplest way is Einstein's equations. But that you should choose the simplest way is, again, a philosophical assumption. It's an aesthetic criterion that the most beautiful or the most simple is most likely to be true. Or it's Occam's razor. Choose the simplest way possible. Don't make things overly complicated, right? Well, those are great sort of, portmanteau sort of working suggestions, but why they should hold, why the simplest formulation should actually be the one that's most accurate, is a kind of mystery. I mean, again, it's a philosophical assumption which Einstein explicitly made, that he would construct relativity as the simplest mathematical representation of the principle of relativity applied to electromagnetic phenomena. Incidentally, that includes the assumption that the speed of light is constant, and that's where you get the paradoxes. To do general relativity, again, it's a relativity theory. He's, again, staying in direct lineage from Newton. He's simply continuing the Newtonian trajectory of all motion is relative, now applying it not just to electromagnetism, but to gravity. And when Einstein was working in the first part of the 20th century, the only 2 physical forces we knew of were electromagnetism and gravity. So in a sense, he did all physics when he did this. I mean, we now have weak and strong forces and lots of complications, but when Einstein constructed general relativity in 1915, that was essentially the sweep of physics, setting aside quantum mechanics. That's another story. But as far as forces were concerned, he had electromagnetism and he had gravity. The way he did general relativity was to assume Newton's principle of relativity. and extend it mathematically to treat the forces of gravity. So even though it's an incredibly complicated theory, it really does represent a very simple philosophical argument. And conversely, Einstein was able to produce a theory which is still profoundly successful, general relativity, based on a very simple philosophical premise, which he explicitly made. That is, motion is relative. Even in a gravitational system of interacting bodies, motion, if you're close enough to each body, the motion looks like it's uniform. He actually worked on a set of principles, which I wrote down here, and they all are interesting to discuss, but they all come out of this underlying principle of relativity. Here's how he represented his principle. It's a very complicated series of equations. You can write them down as one equation, and the terms on the left represent the curvature of space-time through differential geometry, and the terms on the right represent the distribution of mass energy in the universe. And what he's saying is that the way the matter of the universe is arranged, like in stars and galaxies and so on, determines the shape of the universe, the curvature of the universe. And the curvature of the universe determines the motion of the planets and stars and galaxies. So it's a very interesting polarity between curved space-time and the motion of matter, and matter determining the curvature of space-time. There are actually 264 equations here, condensed into one equation. So it's a very complicated theory. But it reflects directly the principle of relativity. So you can go from simple Newtonian mechanics, which we learned as freshmen in college, to general relativity, which you usually get, first, second year of grad school. And you haven't moved an inch from the philosophical assumption about nature that underlies the whole thing. Right? And conversely, philosophy is playing a major, major role in the construction of this theory. Here's a homey illustration of space being curved by the heavy object in the middle, and then the trajectory of planets around that sun. Matter tells space how to curve, and space tells matter how to move. Okay, a quick note on observational evidence. Since 1912 and on, astronomers like George and George's work in the solar system notice that the redshift of light from distant galaxies depends on their distance from us. And they assumed that the redshift, or the fact that the spectrum is shifted towards the red, is due to the motion of these galaxies away from us. So think about a train going by and you hear this whistle get lower, the Doppler shift, the whistle gets lower. If galaxies are moving away from us, their spectrum will be red shifted. If that's true, you can form a simple equation and you get Hubble's law, that the velocity is dependent upon the distance by the Hubble constant h. Theoretical evidence came in to construct a cosmology dependent upon this, reflecting this data from Friedman and Lemaitre and George Gamow and others, arguing that in fact the best way to account for this theoretically is an expanding universe. And the Big Bang is, quote, discovered. Process maybe 20 years, but it's a discovery. In the Big Bang model, there are really, in the original model, there are really three notions of cosmology: the open universe, the open saddle universe, open flat universe, and the closed three-sphere. The first two expand forever, are infinite in size. The third expands for maybe another 1,000 billion years, and then recollapses, and is finite in size. In all three cases, what's really shocking is that the universe has a finite past, about 13.7 billion years. So the universe has not been around forever. It's got a finite age. We're so familiar with this that it's hard to remember how shocking this was in the 1950s and 60s when it was debated and then sort of settled on because of the microwave background discovery in 1966 by Benzias and Wilson. But think about it. Since the early Greeks, right, 500 years before Christ's birth, the idea was that the universe was static and finite. Even Aristotle's universe, which was eternal, was finite in size, never changed. So the only models we had were of a universe that was around forever or created, perhaps, but very finite in size and yet unchanging. This is a shockingly different model. This is the first century in which there is a scientific model of a universe changing in time. Even Newton's universe, let alone Copernicus', was static in time. And it's also a sort of brain teaser. How could the universe be expanding in time? What's it expanding into if it's the universe? Right? So it seems to have paradox written into it, even its conception. Well, as we saw before, we see again, just like Newton's theory of gravity, Newton's cosmology was interpreted right away in terms of a mechanistic universe where life is irrelevant. Right? This universe, this cosmology, was also interpreted quickly by a whole variety of people about whether or not the fact that the universe has a beginning is important, theologically and philosophically. So it all centers around this notion that the universe had a finite beginning, unlike really any other model in the West had ever been. T equals 0, the beginning of the universe. John Wheeler, a very famous physicist and cosmologist, was known to say that T equals 0 is the greatest paradox on the books of physics. How can you think of a universe which has a beginning if that statement is a scientific statement? Just to play it out as an example, if science is committed to the notion that every natural effect is the effect of a natural cause, so my watch is here because I put it there, didn't just sort of appear there. Right? If every effect can be explained as a result of a natural cause, is the beginning of the universe a natural effect? Is it part of nature? Is it something physics could describe? Well, yeah, it just did. And it's natural because it's the cause of the rest of the universe. But it's not the effect of a previous cause, since, by stipulation, it's the first cause. It's the beginning point. It's the singularity. So when physics says, well, the universe began 13.7 billion years ago, can physics say that? And it's a genuine question. It's one of the kinds of questions underlying the T equals 0 argument that have risen to these, what I'm going to show as 3 different responses to the question, do you need to bring in theology as part of the wider explanation of what T equals 0 is about? Or is physics alone enough to deal with it? So it's not just a question of interpretation. It's sort of rooted in the very notion that physics seems to be talking in a way that isn't physics. Okay. And yet it is physics talking. So what do you do? Okay. There are really 3 types of responses to it. One is that T equals 0 is directly relevant to theology. T equals 0 supports belief in God the Creator. Now, Pope Pius XII spoke in ways like this. If you read his statements in the 1950s, 52 or so, it looks as if Pius is saying, yeah, this is the kind of thing we expected to find, since we're Christians, about the universe. This is the kind of universe that's compatible with the notion that it's created by God. Wolfhard Pannenberg, perhaps Germany's best Protestant theologian, will argue similarly that T equals 0 supports the notion of creation out of nothing. That something as radical as T equals 0 in science, right, not in theology or philosophy, but in science, is corroborating evidence for faith in God. And Ted Peters, my colleague, Lutheran colleague, that you can't reduce creation ex nihilo to a strictly philosophical concept. It really has a historical meaning as well, and it's represented by T equals 0. Now, interestingly, amongst those who see a direct relation between T equals 0 and theology is also the atheist Fred Hoyle. Fred Hoyle was an outspoken atheist. As you saw, he was part of the construction of Big Bang cosmology. And he was so outraged by the claim that the universe had a beginning and therefore the apparent support of theism that he was able to construct an alternative theory, steady-state cosmology. In steady-state cosmology, the universe has no beginning. It's been expanding forever. It expands exponentially. It will expand forever. Keep in mind what a profound move this is. Here's someone who constructs an alternative cosmology that works well in science. Hoyle's model was a competitor to Big Bang for almost 2 decades. It explained the same data equally well. So it isn't some sort of weird metaphysical argument. It is a scientific theory. But it was based on a philosophical, theological premise, namely atheism. So to me, Hoyle is one of my heroes, because he's able to show how if you really are convinced philosophically about a point of view about nature, if you're a good scientist, you might be able to find a way to show what that entails about nature in an actual testable theory. Now, of course, the theory has to be testable, or it wouldn't be scientific, and it was testable. And eventually it was proven wrong. Well, every theory gets proven wrong eventually. That's not a problem. It makes it science. What's interesting is that it carries this explicit sort of atheistic umbrella to it, because it's a universe that seems to be self-sustaining. It's never had a creation, never has an end. It's just there. So it's a great example of saying, yeah, t = 0 is really important. I want to get rid of it. And being able to actually do that as a scientist. Right? Now, there are others who take a very different point of view. That is that t = 0 in principle is irrelevant to theology. What counts is the dynamic and open character of the universe, the fact that it has a history, that there's first-generation stars and second-generation, and that we're here on a planet. Life arises through evolution. That's what's important. And the beginnings, don't argue with them. If there was a beginning, it's who cares. Interestingly, 3 of the supporters of this are people who are really interested in supporting and pioneers of theology and science: Ian Barbour, Arthur Peacock, and John Polkinghorne. So you might not be surprised that other scholars would say, I don't care about t = 0. But it's interesting that these scholars do, because they have been so fundamental to the construction of the theology and science conversation. And again, their reason is because they don't want us to be deflected into endless arguments over a very speculative part of theoretical cosmology, namely t = 0. They want us to think about the history of life in the universe, the evolution of stars and planets, the formation of life, and the future of life in the universe. So they're trying to shift our focus away from speculative philosophy and cosmology into what's really important for human life and the environment. A third view, and I would take this, Erna McMullen, the late Erna McMullen from Notre Dame, took this view. Ian has taken it since the 1990s and others, is that t = 0 is indirectly relevant to theology. Science provides confirmation for theology, but not proof. So the primary evidence for our faith is Scripture and tradition, liturgy, personal prayer, family, all those many factors that come to fruition in us. And science might play a secondary role in that, might inspire us, but it is not going to be the source of our faith, nor a primary role against it. Second huge question that comes out of t = 0 is the so-called anthropic principle. And again, it's an interesting example of where science puts forward a new fact, and then we think about it philosophically and theologically and try to come to terms with it. You probably have heard a lot about this phenomenon. It's been written about in many ways. It's a really interesting phenomenon, and that is that the sizes of the physical constants seem just right for life to evolve in our universe. So, just step back a second. The idea that we're really at home in the universe seemed to be challenged by evolution. Seemed to be as if, given the right planet, life will evolve, so why is life so important? That's a huge topic we can't get into tonight. We talked about it in class today, evolution. But the point here is that 100 years after Darwin, scientists have come along in physics and cosmology and said, you know what? Physics plays a very important role in the fact that evolution has occurred in our universe. Had the values of the fundamental constants been ever so slightly different, life could never have evolved in our universe. So if the speed of light or the value of Planck's constant or the charge to mass ratio of the electron and so on had been different in 1 part in 100,000 or 1 part in a million, the universe would be uninhabitable. It would be dead. It would be lifeless. So it poses a really important question. I mean, why is it then that the universe happens to be just right for life? It's called the fine-tuning question. Why is the universe fine-tuned for life? Right? Now, when I was an undergraduate, this was never thought of. It was just assumed that, well, physics could be any way it could be. It happens to be the way it is, and we happen to be here to observe it. But there's no connection between those. The assumption that I got again and again in physics classes was, well, speed of light can be whatever it is. It just happens to have the value it has. And you might want to memorize it for an exam, but it's not significant. Now it's significant. Because if the speed of light were slightly different, you wouldn't have life. So it does raise the question, how do you explain that fine-tuning? Can you explain it within science, or should you legitimately move outside of science to philosophy and theology to explain it? And how do you choose? Which voice does philosophy choose or science? It's a complicated conundrum. Let me try to represent it in a simple diagram. Here's at the top A is a diagram in 2 dimensions of two of the 5 constants, C1 and C2. And the little dotted lines represent the width in variation around the actual value you could have if the universe is to be fine-tuned for life. Right? So that's little error bars you could have for the values of the constants. So the little square where those 2 cross is a little region in which the universe has to exist. The universe has to manifest those particular values within that little square if life is to evolve as it did in our universe. And then there's 2 kinds of explanations of that, or 2 kinds of ways of talking about it. The obviously theological one is God did it, right? Look, this is beyond science to explain. It's a part of t equals 0 which you can't explain, and so it's fair for us to say, well, God isn't acting in the world in some picky way, but if God acts the world in a particular way, that's a different kind of explanation, right? It isn't some sort of intervention because it's about the universe as a whole. It's not about some act in the universe. So God as the ex nihilo explanation is a really valid argument, right? God creates the world, and God creates it such that life will evolve. That makes sense because God wants to create life. Look at the Genesis account, 6-day account, and we're here in covenant with God. Now, almost immediately, George, you remember this period of the 70s, almost immediately there were a variety of voices who said, hang on, you're missing the point. There's another valid, maybe much more valid explanation. If the entire landscape of this 2-dimensional diagram were covered by actual universes, if every possible universe was actual, right, then of course you don't need God because they all exist. And we happen to be in the one that is compatible with us being there, right? Where else are we supposed to be, right? In one of the universes which we're incompatible with? I don't think so. You know, is this the party to whom I'm speaking? Remember Rosanna Dana? Right? You know, I mean, yeah, we're here. That's the point. Every universe is real, and we're in the real one which is compatible with our being here. Now that seems like a pretty good alternate explanation, and it is a good alternate explanation. But the question is, what kind of explanation is it? Well, it was proposed as a scientific explanation. I mean, it was proposed as an empirical explanation. All possible universes are real. And it's based on sort of the laws of science in a way. But it really is a metaphysical argument because it's trying to say that all possible universes, which, and remember, there's no empirical basis for their existence. You can't see them. They're not a galaxy past our galaxy, like Andromeda is outside of the Milky Way. They're a universe beyond our universe. They're a universe for which there's no direct connection. That all of those are real is really a philosophical argument. Could be true. It doesn't mean it's wrong. It just means it's a philosophical argument. It's not a scientific argument in a kind of simple sense that, you know, I can see George sitting there. Well, I can't see these universes. So there's no scientific evidence that could point to them. So originally, it was clear that The many world arguments is the generic for them. The many worlds arguments, meaning many universes, were posed primarily by atheists who, like Hoyle about Big Bang, were annoyed that suddenly there's another kind of argument, namely fine-tuning, which seems to support God as an explanation of a scientific paradox. Again, no one was saying we're putting God into science. This is not intelligent design. It's just saying that there's some points in the history of science and culture where culture can talk about science in a way that's intelligible. Right? And so if the universe had a beginning t equals 0, it's fair to say God did it. If the universe is fine-tuned, it's fair to say God did it. And so as Hoyle said, well, I'll give you a universe in which there is no t equals 0, so you theists can't make a claim. These folks are saying, there's no fine-tuning here. That's an illusion because you're in the universe that looks fine-tuned. But in fact, they're all there. And the point is, it's a legitimate move, but it's not a scientific move. It's a philosophical move just as much as the theistic hypothesis is philosophical. So it has to be debated in a different way. I'm not saying it's wrong. I'm just saying that the debating partners are more on the same level than they wanted to pose themselves as being. Right? The original many worlds people wanted to pose their interpretation as scientific, whereas it was really theological. And the theistic argument was explicitly theological, never said it was scientific. So they're actually more compatible. Now, I want to give credit to the many worlds voice, because over the, 40 years since these debates began in the late 70s, there is more and more credible evidence in cosmology that, in fact, many universes is plausible. So the simplest one is inflationary Big Bang, where the universe seems to be, skewered with domains. It's much more huge than we think it is, and it's got incredible number, maybe an infinite number of domains where different values of the constants arise. That inflationary model is pretty standard today, and it would support the many worlds interpretation. And then you can go on from there even as far as, say, the multiverse and string theory. Now that's getting pretty iffy. But I simply want to give credit to the fact that the non-theistic argument for many worlds has gotten a stronger and stronger voice. And I think it's a very interesting situation that we're in. My own view is that those arguments about sort of bring God in to explain the universe are really iffy for Christians. I think, as we saw, even both in t equals 0 and in many worlds, it's not that simple a move to try to say God is an explanatory, serves an explanatory role in talking about science. It's basically a design argument. The universe has a certain structure. It looks like God did it. My view is reflected by people like Barbour, who say the anthropic principle is not a design argument. Faith is God, and God is not based on science. Interestingly, two other voices for a different view of this, the implications of fine-tuning, come from Freeman Dyson and Paul Davies, neither of whom are explicitly theistic. They're sort of marginally theistic. But they'll argue that there's a very different take on the importance of fine-tuning. It's not so much that it supports a God argument. But if you believe in God, this shows that the universe really is one of which we are at home. That in fact the universe really, our universe, there may be many others that aren't, but our universe really is fine-tuned for life. And however God did that, whether by creating ours directly fine-tuned or creating a multiverse and letting us be in the one we're in, right, that we really are at home in the universe. This is an important voice in culture, because the dominant voice has so often been the Jacques Monod or the Stephen Weinberg or the Richard Dawkins, who will talk about the meaningless universe, the pointless universe, right? It's just there. And what Dyson and Davies are saying, again, not as sort of Christian advocates, but as empathetic to Christian faith, that what they're saying is that fine-tuning is evidence that if you believe in God, it makes a lot of sense that the universe is created. It sort of helps you understand God's purposes, that the universe is that very special one in which life is a key to the universe. It's, in a certain sense, what the fact of biology tells you what kind of physical universe you're in. There's a very close relation between the two. And that's a very different universe than, or mentality than I was raised in undergraduate physics, where physics is what it is, and biology makes no difference. Here we're saying we understand a very close compatibility between our universe and us being in it. Well, I'm going to close very briefly by talking about the frontiers of cosmology in just a couple of slides, and then we'll have time for discussion. So inflation, as I said, solves many of the technical problems of Big Bang, but it leaves T equals 0 undecidable. Inflation is a strange theory, and for someone like John Barrow, he'll say, you cannot answer for technical reasons in inflation, you cannot answer the question, did the universe have a beginning? The answer isn't yes or no, as it was in Big Bang. It's undecidable. So it throws one more sort of interesting twist into this whole conversation we've been having for the last hour about whether the universe is significant theologically, in particular whether T equals 0 is significant. John will say you can't even decide whether or not there was a T equals 0. So you certainly can't interpret it theologically as significant or not, because it isn't even clear there was a T equals 0. And it can't be decided. I mean, it isn't that we don't know. It's that we can't know. That's a very interesting position, right? That you cannot know whether or not there was a T equals 0. So that's an interesting twist in science itself, sort of closing a door to a kind of question which is scientific. I mean, whether it had a beginning or not is a scientific question. And yet, this theory in science, inflation, is closing the door to the question. Right? What a strange, take a look and here it's gone. Right? What a strange situation to be in science now. Quantum gravity, quantum cosmology go beyond inflation. Highly speculative. A lot of scientists like George Ellis, a distinguished scientist, will reject it as being too speculative. But you have these interesting theories that are spawned by it. The first volume that George referred to, produced by the Vatican Observatory CTNS collaboration, was on this precise question of quantum cosmology and what do you make of it theologically. So we've been discussing this since the 90s. And finally, just some religious responses. So Hawking and Sagan, in the brief history of time, will say, without T equals 0, there's nothing left for God to do. And my response is they're attacking deism, not theism. You know, you and I as Christians believe God is thoroughly involved in our life and in the world and nature, not just at a T equals 0 if there was one, which I think there probably was, but that isn't somehow the only place God's acting. So when Hawking writes his brief history, actually in the book itself, as you probably well know, at the end of the book, he says, you know, you need God to put a fire to these equations and produce a universe. He said, I can give you the equations for the universe, but I can't tell you why there's a universe. Right? So Hawking knows that you need a theistic account for why a mathematical description of nature would describe real nature. But Sagan, in introducing the book, takes the exact opposite approach and says, well, Hawking has shown us that the universe has no beginning, and therefore we know there's nothing for God to do. So I think Sagan, who I actually knew pretty well, was a decent man in many ways, but I think he did a disservice to Hawking by twisting Hawking's point and actually taking away from Hawking's beautiful notion that the universe doesn't have the power of instantiating itself, and instead saying, well, if there's no beginning, there's nothing for God. So I think the book is much more profound than Sagan's account of it. And even if you were in an eternally inflating universe, the multiverse, even if that were the case, you know, and astronomers' work showed that really was the case, my response, of course, is still the stable argument of Christian faith since St. Thomas first gave it to us, right, in his reading of Aristotle, which was a scandal, right, in Paris. But in fact, it's a profound reading. He says, well, even if the universe is infinite in age, like Aristotle says, you still need God to explain why there's anything and nothing. So there's the fundamental argument that any universe, in other words, anything that exists, especially any universe, begs the question of why it exists. And the legitimate answer is not going to be, well, because it came from something else, because that's an infinite regress. That's what, of course, Thomas knew. The entire regress begs the question, well, why does that exist? And at some point you get tired and say, well, that's God. I mean, that's what God's explanation is. It's the explanation of the entire series. God explains contingent being because God is necessary being. Okay. So rather than a sharp distinction between physics and biology, or between cosmology and evolution, nature and history, that's a classic 19th century argument, or science and philosophy, theology, the universe is a historical reality. It has an unrepeatable past, first-generation stars, second-generation stars, planets, life, maybe life in the universe, E.T. It has a unique present. We're here. We really are here. and somehow God's intimately involved in that, in an open future, right? The universe will continue and God will be involved in it. So we are truly at home in the universe that God has created for our life. Even the meaning of, we're even in a certain sense the meaning of the universe. And this has vast and as yet hardly tapped potential for Christian theology, Christian ethics, and Christian spirituality. So, theology, philosophy, and science can be partners in creative mutual interaction. And I close with this wonderful quote from beloved John Paul II in the book that George published in '88, Physics, Philosophy, and Theology. Science can purify religion from error and superstition. Religion can purify science from idolatry and false absolutes. Each can draw the other into a wider world, a world in which both can flourish. Isn't that a stunning statement? Thank you, John Paul. Thanks.
So I doubt that there are any questions since Bob has given all the answers. All right. I would suggest one thing. I think if questions center upon what I saw as two central issues, that is either the t equals 0 discussion or the fine-tuning of the universe discussion, if you can identify whether you're coming from a philosophical, theological, scientific, theoretical, or scientific, empirical background. Or if you don't know, don't tell us. Because many times we cannot identify. Let me give you an example before I open it to questions. I, as an empirical scientist, consider the t equals 0 as a non-question for empirical science. Because though we have a lot of solid evidence that the universe is expanding, and we can date it back to a time when it began to expand, 13.7 plus or minus 0.2 billion years ago, that's an empirically established time, we cannot empirically ever identify anything beyond 10 to the minus 43 seconds before it began. So t equals 0 is not identifiable empirically by an empirical science plus a theoretical interpretation of quantum physics. So that's what I mean by identify what you're talking about. I will say another thing. If I identify myself, which you will immediately dismiss as knowing any philosophy or theology, but I'll give it a try. T equals 0 has nothing to do with theological idea of creation. And Bob and I will contest this, because the theological idea of creation says three what I consider negative things. It says everything that does exist came from God. Everything that does exist came from God because He made it out of nothing that previously existed. Now, previous is kind of a time word, so I'm getting in trouble there. But there was nothing. And the nothing was not a bunch of something from which God made the universe. There was nothing, whatever that means. And third, that everything that does exist totally depends upon God. So there are three kind of negative statements. Well, I don't want to present myself. What I want to give you an example of, if you're going to ask a question, present a point of view, etc., it'd be very nice if we kind of knew where you were coming from. Are you a scientist, empirical scientist, philosopher, theologian, or a whole bunch of everything? So let's open it up, because I don't want to... If you'd approach the microphones, that would be very nice. And maybe identify yourself besides whether you're a philosopher or scientist. Don?
I'm Don McCrimmon. I don't know what I am. I'm trained as a scientist and an empirical scientist. And I've had an ongoing conversation with many people, including myself, about the interface between science and religion for a long time. Not entirely coincidentally, this afternoon, I watched the snow come down outside my window, and I finally wrapped up reading Jim Holt's book, Why Does the World Exist?, where he looks at the philosophical foundations of answering the question, why is there something rather than nothing? And George just touched on this in an important way. And he kind of comes to a conclusion that there are two best explanations. Either it's because it's the simplest thing to imagine that the world exists because it's the simplest thing to imagine, or maybe there are many worlds and we're just one of them, and you touched on that in your remarks. The implications for both is that the universe is going to end up being, interestingly enough, according to his interpretation, a pretty mediocre place. Neither good nor evil, but somewhere in between. And I didn't find that very satisfying at the end. But I was kind of intrigued by your last slide, where you talked about theodicy. And you seem to be heading in the direction of the multiverse or the many worlds interpretation for the answer to the question, why is there something rather than nothing? And I would appreciate it if you would expand on that a little bit. Thank you.
Okay, thanks very much. Great question. As a scientist, I'm really uncommitted to a single universe or multiverse. I mean, as a scientist, I say the technicalities of the question. And it really goes to whether or not scientists will support string theory. And that's the basis, or superstring theory is the basis for multiverse. And I think the field's really divided. And I really want to respect that, because I know my limits as a scientist. So I can understand the debate, but I'm not the one to speak for it. From a philosophical point of view, I can see the virtue of a multiverse in that it even more fully expresses the possibilities of nature, but it also is so sort of overwhelmingly loaded with the problem of evil, because if the multiverse were true, it would seem as if every possible reality would occur, and in one of those Hitler wins, and one is worse than that. So I don't mind having better scenarios in our history, but I certainly would be distressed at having worse ones. And that's exactly the reason why George Ellis and Bill Steger reject the multiverse, even though they'll do it for other reasons. Behind it is the problem of theodicy, written on a grand scale. Now, as a theologian, I think what's important, and I was trying to say this at the end, is that however we got here, I don't want to diminish the fact that we're here. There is a true gift to being here. There's a true gift to being in a universe in which being a biological creature is very compatible with being a physical creature, because being a biological creature is compatible with being a psychological creature, and therefore a self-conscious creature in God's image. So there's more of a sense of at-homeness, and I mean in the full sense of humanity, gifted with Imago Dei and covenant, in this universe. So I'm not as concerned about whether we got here because it's one of many universes or it's the precise one God created. I agree with the folks, including George, although I don't agree with his reasons entirely, for saying t equals 0 isn't part of it shouldn't be part of this issue. I think it's true, although it's an important question. Thank you. Yeah.
Hi, Paul Welch, man in the street who watches television and sees reports about Higgs boson and how this can recreate the Big Bang Theory. Talk about it. Tell me how Higgs boson and a possible Big Bang would impact any of the things you've said tonight.
Thank you. Just real briefly, what's unusual about the Higgs boson compared to the other elementary particles is that it seems to be the clue to the spectrum of masses particles have. That is, if you forget the Higgs boson, you're left with the question of why the elementary particles, the mesons and so on, have the values, the masses they have. You can guess at the ratios of the masses, but you can't typically explain the actual masses. So in that sense, the Higgs boson comes along in a double role of being one more particle with mass, but also being the particle which sets the sort of scale for masses. And that's why in the colloquial said the Higgs boson or the Higgs field gives the masses to the particles. It's a fairly decent sort of colloquialism for what the Higgs boson does. Now, I want to respect the fact that that's a scientific explanation. You can give it a philosophical or theological interpretation, but again, that's an interpretation. It's not in the physics. Right? So when people talk about it as, you know, being the God particle or something, I think they're trying to say that it has a certain fundamental role that other particles don't have. But I'm wary, I think I would share this with George very much, of over-theologizing or over-philosophizing a fact like that in physics. So I want to accept its unusual role within physics. If you really want to press it, okay, an important philosophical element in the notion of the Higgs field is that it seems to accentuate the difference between properties that particles possess, like how many hairs are on your head, and properties which arise as relations between particles. Like my relation to Charlotte is husband and wife. It's not being husband isn't a property of me. It's a relation between me and Charlotte. So I have both properties and relations, and they're both to be honored, right? And oftentimes, you know, in individual society, you forget that relations are super important. So it is true that, in this sense, the Higgs field is more a phenomenon of relation than it is a phenomenon of property. So it's in a certain way, as long as you don't make too much of it, it's quite beautiful that even at the level of elementary particles, there is a distinction between particles with properties, like the like the charge of an electron, or particles with relations, like the masses given by the Higgs boson.
So would you recommend counseling for the particles?
Yes. Counseling is good.
My name is Don Hughes, and I'm an adjunct here. My background is in chemistry, so I guess I'm a scientist. They're having me teach physics these days. Dangerous. So I wanted to talk about more about the T equals 0 idea. And it seems to me that well, it reminds me of the creation story that just about every culture on the planet has come up with, right? A story that explains how the world came to be. And this is consistent with that. This happens to have some scientific underpinnings to it. But humans have been doing this for a long time. You know, the American Indians had the turtle, and the world came on the back of the turtle, and so forth. We've got Genesis, and et cetera, et cetera. So here's my scientific question. When you go backwards in time, and you come up with this age, and the universe started as this pinpoint. It seems kind of audacious to me that the physicists can expect to be able to explain what's going on when the universe is in that extreme state. I mean, right? So Einstein had to come up with the theory of special relativity to explain things going at the speed of light or near the speed of light. Why is it that we can think that we can explain what's going on when the universe is the size of a ping pong ball? And still has all that mass.
Yeah. Thanks. That gives me a great opportunity to respond critically to George without saying so. When I was a grad student, the explanation was given. The reason why we talk about T equals 0 as empirical is not because there's direct evidence for it. George is absolutely right. You cannot have direct evidence for T equals 0, precisely because the closer you get to T equals 0, the crazier the physics is, and the more unobservable it is. The temperatures go ballistic, right? You've got what becomes cooler temperatures, background radiation. At hotter temperatures, you have a plasma. Nothing can escape. There's no way to observe it. It's crazy. The reason why physicists talk about T equals 0 as real is because of a theoretical argument, not an empirical argument. Now, if you want to rule out theoretical arguments, you're not doing physics. You're doing Aristotle. Right. But if you want to look at physics today, it's a combination of theory and evidence. And the theoretical argument comes from a set of so-called singularity theorems by Stephen Hawking, George Gorosh, Roger Penrose, and George Ellis. And they're published in a book called The Large-Scale Structure of Space-Time. These singularity theorems say the following. If general relativity is the correct theory, and in the 60s it was, and if the universe has a net positive total mass energy, and it does, then there has to be a singularity, and what's called an essential singularity, someplace in the universe, and that's T equals 0. An essential singularity is not removable by changing coordinates. So a coordinate singularity is the North Pole. You go to the North Pole, every direction is south, but nothing physically is going on that's crazy. It's because of the way you describe the North Pole. But if you're in a straitjacket, you can think I want to walk out, but you can't because you're confined by it physically. T equals 0 in Big Bang cosmology is a physical singularity, and it's an absolute singularity. So the reason why physicists talk about it is not because they have a theory of the dynamic processes that lead to it within the plasma. You're right. And George is right. You cannot observe it, and you can't describe it by physics. In fact, that's the whole quest for unified field theory, to describe what's happening before the symmetry breaking at the first three minutes. But the reason why physicists talked about T equals 0, because they weren't crazy. They're physicists. They're not talking about non-empirical stuff. Because the data they had supports general relativity. And general relativity supports a T equals 0. So you can't play physics and forget you can't say heads or win, tails you lose. If you're going to do physics and that says that, it says it. Now, what happened was, of course, while theologians were off talking about it, physicists continued the problem. And the way they got around T equals 0 was by inflation. Because inflation both answers other problems in near T equals 0, like the horizon problem, the antimatter problem, and 3 or 4 other ones. But it also, according to John Barrow at least, argues that the question of T equals 0 is undecidable, and the reason why it's undecidable is because the claim that the total mass energy of the universe is greater than 0 isn't clearly true. So the condition of applicability of the singularity theorems is not obtained, and therefore the singularity theorems don't necessarily apply. Therefore, you can't answer the question whether or not general relativity includes an essential singularity.
So I guess the follow-up is, what if general relativity is wrong in that situation? Then
okay, the response to this, the standard response. General relativity is wrong at some point. It's not quantum mechanical.
Right.
It's classical. So it is wrong. But until you have a replacement theory, and this is the beauty of physics, this is physics humility, it really can't talk about the wrongness until it knows what's right about it. You don't know what's right till you know what's wrong about it. This is exactly the point of classical physics. I can tell you exactly what's right about classical physics. It's right as long as the speed of light, it's small compared to the speed of light, and large compared to Planck's constant. So there's a clearly defined domain in which classical physics is right. We don't know those domains because we don't know the replacement theories, that is quantum mechanics and special relativity, were to classical physics. We don't have those for general relativity, unless you believe in string theory. If you believe in string theory, you'd say we have the replacement theory, because string theory unites with quantum mechanics to give you string theory unites quantum mechanics and general relativity. But then you get into the debate over string theory. Again, George's kind of argument is there's no evidence for string theory. Mm-hmm. And then you get into the debate around that. So all I mean to say is, yes, GR is probably wrong in lots of ways. We don't know what they are very well yet. So then it's a matter of how you do your physics, whether you work within an existing theory, knowing it's probably going to be wrong, or whether you try to find its replacement and get into dodgy, iffy language. But just saying, well, since it's going to be wrong, why take it? You need to say this. But if someone said, well, why do I take it seriously? It's going to be wrong. That's just dodging the question. If you want to play theology and science, you've got to deal with the science you have.
Thanks.
Otherwise, you're playing heads or win, tails you lose. Yes, please.
Before, could I add a word, Bob?
You're responding to him now.
No, I'm adding a word to this discussion because you mentioned my name.
I did. As you mean.
I'm speaking as a very, very limping philosopher. I mean, limping. But it appears to me this discussion leads me to a conclusion, temporary conclusion, very provisory conclusion, that a scientific theoretical construct to explain the best empirical evidence is intrinsically limited by the empirical evidence. Namely, that Bob's whole discussion of a unified field theory, etc., requires a t equals 0. I can't get into the details because I don't know the details. I think more to me, as an empirical scientist, reveals the inadequacy of a theoretical construction that does its best to explain empirical evidence. That the empirical evidence always goes beyond our ability to explain it by the best of scientific theoretical constructions. Therefore, the requirement of t equals 0 is inadequacy of the theoretical construction. But you may want to say a word to that. I'm sorry to have intervened. Jennifer.
Hi, I'm Jennifer Glancy, and unlike a number of the other speakers, I'm not a scientist. I'm I'm trained in New Testament. But the comments I want to make are actually based in Hebrew Scripture, because it seems to me, just to throw another wrinkle in this, that you're assuming theologically that Scripture speaks of creation ex nihilo, and I think you probably know that's pretty contested. If you actually read Genesis, Bereshit bara Elohim, we translate, in the beginning, but it could also be translated, when, at the beginning of when God created. It's not necessarily that absolute beginning. And the creation is out of what, tohu vavohu, we can pronounce it different ways, but it's unclear that that means an absolute nothingness, and I think you've probably encountered those ideas before. So I just wanted to complicate this a little bit by saying that it's also problematic from the theological perspective. I know how Genesis has been interpreted, particularly in Christian tradition, but not always in Jewish tradition, and it's not as absolute and neat. So I don't know if you want to comment or not, but I just thought I'd throw that in.
Yeah. Well, thank you very much. You're absolutely right, and I'm very aware of this problem. I think you're right. So what I would have meant to say in a longer conversation about scriptural warrants for the argument versus historical construction in the patristic period or whatever is to say that you have, as you say, a very mixed way of reading Genesis. And one reading will give some warrant for it, and of course Thomas Aquinas used that. Others will not. Right? They'll give a very different account of kind of a continuous creation out of disorder into order, and simply don't speak to a beginning. I mean, I'd say you could say the two interpretations are: one supports a beginning, one is ambiguous or doesn't speak to it. Kind of like John Barrow saying it's undecidable, right? And so, in some of my writings, I try to say, well, you have these different accounts, and then identify which one I'm going to take. It's kind of like my work with resurrection and various accounts. So thank you for that comment. I certainly would not want to do any kind of proof texting, and I don't think anybody in the field actually does that. I think most of us are pretty aware that ex nihilo, like Trinity, right, are theological synthetic moves in the early patristic period, and I wouldn't want to rule those out. I mean, I don't want to rule out the Council of Nicaea or something, but I also recognize that it's not some sort of literal reading of Scripture. So thank you for your comment. Very helpful.
Thanks.
Okay, I have a question in regard to empirical science and also theology. In regards to the Big Bang, I know measuring the cosmic background radiation from that event, they can determine, pretty close to the time that it actually happened. But what I am not really clear on is that it is said that everything emerges from the Big Bang, but emergence is a descriptive, not an explanatory concept. So as I listen to some of this, I'm thinking in terms how there's really not commensurability between the mind of God and the mind of man. And so we have God operating, as it were, from the top down, and science operating from the bottom up. And so we have a situation where empirical science considers the basis of everything to be matter, where it would seem to me that that the foundation of everything could be considered more consciousness, which would bring us closer into a situation of more of a religious interpretation of some of the things that science is trying to understand. And so my question would be, as we're moving towards like a theory of everything, and science is, rapidly progressing, do you feel that the human mind and human consciousness will keep pace with this type of situation?
Thank you. Well, you've said a lot. Let me just take one little piece out of it and then ask for your question. I think Christian teaching across denominations is that we're more than conscience. We're some sort of psychosomatic unity. So that mind is important, spirit's important, but so is matter. Science might, at least natural science, might be limited to matter. But we are, to studying matter. But we are, a living being. We are an animated body. We are a rational animal. We are infused with God's breath and spirit. So I want to avoid saying that consciousness is the most important factor in nature, or that we are primarily conscious. But it is an amazing fact that we're conscious, because atoms aren't, rocks aren't, right? Plants aren't, but we are, and we come from them. So how to sort that thing? You've opened up a series of really interesting questions for just a different kind of conversation. Thank you. Yeah.
Hello. Hello, my name is Scott. I'm an upstate New York dairy farmer.
Hi. Good.
I've got two questions. The first is, can science explain the virgin conception?
Okay, what's the second?
The second is, in your life, what is the most amazing discovery that's ever been revealed to you?
Gee. Well, I think there are two kinds of most amazing discoveries. One of the kinds you get existentially with the birth of your kids or falling in love. Those are absolutely astonishing experiences which probably go beyond understanding. Personally, I'm a physicist. I love relativity and quantum mechanics. And the view of the world I get through studying those theories is absolutely astonishing. So much more rich than our ordinary experience of life. So I have to admit, science does play an amazing revelatory role about the very nature that we're a part of. But it doesn't match in any way the kind of astonishing revelations in personal life that I've been blessed with in my relation to Charlotte and our kids. Virgin birth, let's assume that that's what happened. I don't think science can speak to individual events in that way. Even the laws of physics have exceptions. There are extenuating circumstances, even in simple laws of physics. You can't know all the factors in the universe that you can sort of nail down such that all else is equal, so you can really make a prediction from science. So let's take the virgin birth as a fact. I would say science cannot disprove it, nor prove it. It's an anomaly to science, just as much as your own life and personality and experiences. Science can't account for them all. They can give general descriptions, but you are a true mystery that transcends any sort of intellectual representation. Just as George was saying, the empirical facts of your life and of Mary's go beyond any theoretical construct. Our theories are always, in the end, abstract descriptions of concrete realities. And therefore, they can't capture all of reality because the map isn't the territory. So, stepping aside from the fact of the virgin birth, I don't want to speak to that. That's a sacred issue. Assuming it's true, right? It simply isn't something that falls within the jurisdiction of science to prove or disprove. It might lay certain questions about it. You know, I mean, how does Jesus have the same DNA as you and I do? But it's not the kind of question. I think there's a much deeper question that science might raise to something like the resurrection and the transformation of the universe into a new creation. I've spent a lot of time working on that. Because that entails so many more things that we already know about in science that makes it a very challenging question. But I want to give a lot of respect for and leeway to the kind of faith question you're speaking of, and really do justice to it and honor it. And also, as George said rightly, to underscore the fallibility and the partiality and the modesty of what science says. Physics is really successful. It makes these globalizing statements like the universe is expanding because it simplifies the problem. When it says, just one example, when physics says the universe is expanding, the data, of George's data, is drawn from the distances between clusters of galaxies. It doesn't talk about the structure of galaxies. The galaxies aren't expanding. Stars aren't expanding. You and I are not expanding. It's the distance between clusters of galaxies. Our cluster and the Virgo cluster is expanding. That's how abstract the concept of expanding universe. Whereas when I talk to it in school, you think sphere blowing up, every point's expanding. And that's not what it means. So I want to step back and respect the modesty of scientific claims. It's not to say they aren't powerful, they aren't globalizing, but they just don't have thank goodness, they don't have the authority to get at something as holy as a virgin birth.
All right. Thank you.
You're welcome.
Okay, Bob, as I announced, let's take a 5-minute break at least. There's a reception.